All right, Rollins asked me about number 5 on 7-6 linear programming. So the problems are written above. You can pause it and read it. I'm going to keep working here. Start the problem. Okay, so I know that what I did was I said, let's let my x be the number of units for the 250 at $250 units. And then I said, let's let y be the number of units at the $300 cost. I know that the x has a profit of 25, and I know that the second one has a profit, the y has a profit of $40. All right, so I also know, so I have to figure out what kind of constraints do I have. The merchant wants to have $71,500 in inventory. That means that so my first constraint is going to be, so I want the $250 times x, the number of units I have of this MP3 player, plus the $300 times y, the number of those units, needs to be less than or equal to 71,500 to maintain that much inventory. All right, then I also know what the profit is. Profit is what I'm trying to maximize. I also know what the cost is. The number of units. The demand. The demand will be 260. So I don't want to produce more than that, because if I do, then I just have excess lying around. So the number of units x plus the number of units y needs to be less than or equal to 260. So these are my constraints. So this is what I want to maximize is how much my profit will be. So what's the optimal inventory level for each model? So I want my objective function is going to be my profit. So if I make $25 per x and I make $40 per y, we could call this, I can't remember what we called it in the video. Did we say P is equal to? I can't remember. I did that video a couple days ago. All right, so let's start by, I went ahead and graphed. Do you have to? Well, you do need to find the vertices, right? So I guess technically you should. So let's make the first constraint blue. What I did was I created, I've changed it to y equals mx plus b formatting. No, actually, I think I did the intercepts. So for the intercepts, if I want to find the x-intercept, that means that y is 0. So 71,500 divided by 250 would be 286. So that's where it crosses the x-axis. It's going to cross at, and I've labeled these. Remember I said that in the video that we need those. We have to check them. So label them. And then I want to find out where this guy crosses the y-axis. That means I plug in x for 0. So I'll get 71,500 divided by 300, which gives me 238.3. So it's going to be, I'm going to put it over here. We're going to put that point right here. And I'm going to actually put it in as an exact, because when I check it later, I want to make sure that I'm plugging in the correct number. And I got 715 over 3 when I just simplified that fraction. All right, so that guy, that's the graph there. All right, my next one, let's graph in red. That's this guy right here. So we know that x plus y has to equal 260. So again, I did the intercept method. If I want to find the x-intercept, I plug y as 0. So that means x would be 260. So all that mattered to me is that it was before the 286 here. So this is going to be 260, 0. And then the y-intercept, where x is 0, actually happens to be the same numbers, also 260. And it's actually above here, so if you convert to 715 over 3, that's 238. So I need to know that this guy is above this intercept is. So this one is 0, 260. And let's draw a line between our two graphs. All right, so my shading, notice that I have two different sections. This is one section, this is my other section. So I have several vertices. I have one here, I have one here, I have one here, one here, and one here. I have everything except for this one here. So let's see if we can find that guy. That's the point of intersection. So I think I just plugged in to find that point of intersection. I just plugged one into the other. So 250x plus 300, y would be 260 minus x if I plug in this second equation into the first. And that I just set it equal to because we're not worried about the inequality portion. And when you solve this guy, you should get x equals 130. And then if I plug it into this second function here, you can figure that out real easily, that the y must be 130 as well. That's the point of intersection. So you remember we're supposed to test all of these vertices. So we test in our objective function. Our objective function is 25x plus 40y. P is equal to is what I said. Profit is equal to. So we test each one of these in. We test P. I don't know if you noticed this, but two of them you truly don't have to test because logically speaking, this guy is going to be less than this guy and this guy is less than this guy. But check them all if you didn't see that off the bat. So when I plugged this, oops, not y, I'm sorry. That's not supposed to be y right there. That's supposed to be 260. Oh, goodness. This gave me 10,400. Then I tried the next one. Again, you could check the second one below it, but I honestly don't even care what it is because I know it's smaller than the one above it. It gave me 9533.33, but I know that's smaller. That's clearly not going to maximize things. So I checked my P is, I tried the 286 plus 40 times 0. Tried this one right here. And this one gave me 7150, I think. I'm looking correctly at my notes. That's not gonna maximize. Again, I said you don't really have to check it, but if you didn't recognize that, check it anyways. It's still gonna come out just an extra step along the way. This one I think gave me 6,500. Not maximizing. I have one more option. That would be that point of intersection, 130 and 130. So check the profit at 25, 130 plus 40 at 130. I came up with 8450, which also does not maximize. So it looks like this is the one that maximizes my objective function. If I sell 0 of the $250 units, and I sell 260, all of my inventory of the $300